We've always been fascinated about our origins as humans, and that fascination has always motivated us to explore beyond our planet's boundaries. Scientists are attempting to answer problems such as how did our world originate, and whether or not we are alone in this universe. They've been struggling to figure it out for a long time. The James Webb Telescope is a beginning for the questions we have. And after waiting for a long time, the James Webb Telescope has arrived as its target location, ready to answer our questions. But what is the James Webb Telescope? Can this finally answer our questions? And what did the telescope see? Keep watching to find out more. The James Webb Telescope is the world's most powerful and largest space telescope. It will let scientists peek back 200 million years after the Big Bang to see how our cosmos looked. Images of some of the first galaxies ever formed will be captured by the telescope. It will also be able to peek inside dust clouds to see where new stars and planets are developing, as well as investigate the atmospheres of planets orbiting other stars. It will be able to observe objects in our solar system from Mars outward. The James Webb Telescope is the successor to the Hubble Space Telescope. But what is the difference between the James Webb Space Telescope and the Hubble? One of the differences between them is the orbit. The Earth is 150 million kilometers away from the Sun, and the Moon orbits us at a distance of about 384,500 kilometers. The Hubble Space Telescope orbits the Earth at a height of 570 kilometers above the surface. Webb will not circle the Earth, instead, it will sit 1.5 million kilometers distant from the Earth. Hubble was able to be launched into space by the Space Shuttle because it is in Earth orbit. The Webb Telescope will be launched on an Ariane 5 rocket and will not be serviced by the Space Shuttle because it will not be in Earth orbit. The Webb Telescope sees the universe in light that human eyes cannot perceive. Infrared radiation is the name for this type of light, which we perceive as heat. The Webb Telescope will see through dust in our universe with its infrared cameras. Inside those dust clouds, stars and planets originate, thus peering inside could lead to intriguing new discoveries. It will also be able to observe objects, like the early galaxies, that are so far away that their light has shifted from visible to infrared due to the expansion of the cosmos. But what is the meaning of infrared observations in astronomy? Stars and planets in the early stages of formation are obscured by dust cocoons that absorb visible light. The same may be said about our galaxy's nucleus. Infrared light released by these places, on the other hand, can pierce the dusty veil and expose what is beneath. The Webb Telescope has a lot of mirrors. Mirrors capture and focus light from faraway stars, allowing space telescopes to see. The larger the mirror, the more details may be seen by the telescope. Launching a massive, heavy mirror into orbit is quite challenging. As a result, engineers created 18 smaller mirrors that fit together like a piece in the Webb Telescope. The mirrors fold up inside the rocket before unfolding in orbit to form one huge mirror. The mirrors have a thin layer of gold because it helps the mirrors reflect infrared light. NASA, the European Space Agency, ESA, and the Canadian Space Agency collaborated to create the James Webb Space Telescope. According to NASA, nearly 300 institutions, organizations, and enterprises from 29 states and 14 countries participated in the Webb Telescope. The Webb Telescope is expected to last 5 years, but the target is 10. The Webb Telescope was supposed to launch in 2007, but astronomers' patience has been put to the test since then. Numerous delays have been caused by a combination of engineering concerns, political hesitation, and project management issues. Politicians in the United States threatened to cut funding for the Webb Telescope in July 2011. The spacecraft was rescued in November 2011, after a tense few months. The launch of the Webb Telescope was then postponed in March 2018 owing to spacecraft technical difficulties. In June of that year, an independent review board suggested that the launch be postponed until March 2021. The global coronavirus, COVID-19, epidemic hampered the Webb Telescope's work in 2020, and NASA announced a revised launch date of October 31, 2021 in July of that year. Despite the Webb's team tenacity and dedication in the face of difficulties, the delays continued. The launch date was moved back to November or perhaps early December 2021 due to issues with the Ariane 5 launch vehicle in June 2021. The observatory had not even been moved from its original position in California to ESA's launch site in Kourou to French Guiana, when NASA and ESA announced yet another delay in September. The two agencies set a new launch date of December 18, but inclement weather intervened. Finally, on December 25, 2021, The Webb telescope was launched on board an Arianespace Ariane 5 rocket from ESA's launch facility in Kourou. All of the team's hard work has been paying off since the launch on December 25, 2021. The launch went off without a hitch, the telescope has enough of fuel, and everything happened just as planned. Since the Webb telescope arrived at its orbital destination on January 24, 2022, the mission operations team has successfully turned on all of the telescope's science instruments, including its primary camera, the near-infrared camera or NIRCam. Turning on the instruments is the first in a sequence of important actions that includes turning off heaters to begin a protracted cool-down process for the equipment and aligning the telescope's mirrors over a months-long timeframe. These readings from the NIR can allow scientists on the ground to begin aligning the telescope's 18 mirrors to create a new lens on the cosmos. According to NASA, the photographs taken by the Webb telescope at this time will not be amazing, but they will serve the objective of preparing the telescope for science. Each of these parts would be oriented towards a different section of the sky in order to take the initial photograph of the star. According to NASA, each of these parts will capture different photos of the star that will be patched together later. To accomplish so, each segment of the entire mirror must be exactly aligned, according to NASA. The segments must be lined up with each other with an accuracy smaller than the wavelength of the light, NASA said. So, after a lot of debate, NASA finally revealed to the world that the first target of the Webb telescope will be a lonely star located in the constellation Ursa Major. This bright and lonely star named HD 84406 will become everyone's center of attraction, despite the fact that it is around 260 light-years away. First light is required for the next stage of aligning the 18 beryllium and gold segments that make up the Webb's mirror, bringing each segment into the proper place to function together precisely. This involves validating on the Webb telescope that photons can enter the telescope and appear on its detectors. This is necessary for the following stage, which involves aligning the 18 beryllium and gold segments that make up the Webb's mirror to ensure that they all operate together flawlessly. The group must fine-tune their respective places in any final by focusing on the star HD 84406. But, what are photons? Photons are the tiniest conceivable packets of electromagnetic energy, yet they're so common in particle physics that you nearly forget about them. The photon has powered centuries of research, and it continues to be a significant instrument today. This data is crucial for the next phase in the Webb telescope's science mission, as well as for acquiring actual photos that we on Earth can marvel at. When the Webb telescope looks at HD 84406 for the first time, it will create 18 somewhat distinct hazy photos of the star. Engineers will have to match each image to the correct segment once they know which segment is generating which image, which will be more challenging than matching each image to the correct segment once they know which segment is generating which image. Because each mirror segment moves at an incredibly slow rate, especially in the micron and nanometer regions, the mirror unification process will take 3 months. The Webb telescope has now completed the one task that telescopes are designed to perform: it has detected photons. The first step in the telescope's journey to uncover our cosmos has been made. Later on, the telescope will answer our questions about if we are alone in the cosmos and how everything began, as well as sending us photographs to demonstrate how wonderful the universe truly is. Are you looking forward to finding out the answers to our questions? And to see images that the telescope will send us? Let us know in the comments.